Well, so the area of research that I work in is called empirical software engineering. And the word empirical here really means based on observation. So a lot of what we do is trying to understand how I could measure different software engineering practices, or look at how software engineers are performing in the real world and understand, are there recommendations or guidance I could give them about better ways to do it. So a lot of the interesting part of it is, of course, you can't really do this kind of research sitting in a dark office by yourself measuring things that don't exist. And so a lot of it is done in partnership with different teams. So I've worked with a lot of software engineering teams across industry, across different government organizations. It's been a really wonderful way not only to do research that I find personally rewarding and interesting and publishable, but also to learn a bunch of different domains. And so to understand how software gets done in all kinds of different environments. We've worked with teams that are especially doing government work where it really has to be perfect. I've done a lot of my career working with NASA. And especially if you're talking about manned spacecraft, then you don't have a lot of margin for error there, and it really does have to be zero defect or perfect. As well as working within other environments where the goal is really to deliver the software as quickly as possible, get it out and get market share. And so those are two extremes, and they drive a lot of different practices. They drive a lot of different priorities and a lot of different, just people, what they find personally rewarding about doing the software varies from team to team as well. So it's really been a wonderful chance to get out and just talk to software developers, understand what makes them tick, understand different priorities and how they do their day-to-day jobs, and then do good research that can help them achieve the various goals that they have in mind. So a lot of the work that I've done with NASA, like I said, has been working with teams across the agency. Some of the things that they've been interested in are just how do I upfront make a set of decisions about the software so that, so these are teams, I should say, that are doing software but as part of a larger mission. So there's a lot of software decisions we'd like to make, but they all have impacts on the rest of the mission, on the cost, on the capabilities, on what the mission's able to achieve. And so a lot of it is, first, what kind of rigorous processes can I give you to make those decisions in the right way, to know what to look for leading indicators that perhaps I've made some of these upfront decisions about how to structure the software wrong, and so that I can make corrective actions. So there's a rigorous technical side, and then there's a kind of a more of a personality-driven side, I guess, which is that these missions bring together so many experts in different areas of expertise. So not only software engineering, but mechanical engineering, electrical engineering. How do I have those negotiations up front in an effective way to make sure that what we're going to develop as a team is really the most effective? And so, like I said, that we have a certain set of technical principles behind that that we've put in place. We've been able to measure the impact. And so here, when I talk about measurement, we're looking at things like, well, how costly is it to do these types of negotiations up front? How costly is it to do the reviews of my software artifacts to make sure that they're good quality? And then in terms of the output, how many corrections do I make? If I launch into this process and I'm not changing anything, well, that probably says the process wasn't all that great, or it wasn't the right place to do the intervention anyway. So, we look at outcome measures such as the number of defects I've been able to fix, or the number of changes, the number of things I've made better in that system. And then I have a sense that, yes, the intervention that I've done as a researcher and the practical things that these developers have put in place are actually making a real difference to the mission and to the way NASA develops its software, let's say. One of my guilty secrets, in a way, is that my undergraduate degree, it was in computer science, but it was from a liberal arts college. And I think it did kind of expose me not only to be interested in the technical pieces and have that technical grounding, because without that you don't have the credibility to go out and make these interventions. But also to be interested in kind of a lot of the larger parts of the world, and how software interrelates with all these other things that we're trying to do, and bigger priorities, other system engineering types of principles. So I think that the answer to the question is that a good grounding in computer science and software engineering in particular is necessary, but certainly having curiosity about how people use the systems. What does this mean? Not only at the technical level, but how do people use these technologies? How do they really perform in practice? A lot of what we see is that there's good research that goes on, and I can create very detailed technical solutions, and then they're too complicated for many software developers to actually use with the time and the resources and the background they have available. So I think looking at not only having a good grounding in the technical side, but how does that technical part relate to the human aspects of it is my background, and it's part of the job that makes it so interesting to me, actually. Well, two things, I think. One is to not only to be, get that good computer science grounding, but to be curious and to take advantage of your time as an undergraduate to, explore other fields and get a sense of things, even if it doesn't contribute to a major or a minor degree. I think that one of the things that influenced me personally was a computer science paper called "The Software Engineer as a Toolsmith." And it really mentioned, that so much of what we do as software engineers is to develop tools for other people to use. And I think launching into the marketplace and having the software engineering skill set, but also understanding the background of other people, the people that we're working with, the people that are going to be using our software, understanding a little bit about their domains and what makes them tick and what are the technical underpinnings that they're dealing with on a day-to-day basis is very valuable. And the second thing I like to give as advice to undergraduates is not to feel that you have to lock yourself into a kind of a cut and dried career path. So personally, I've been very lucky with my career. I haven't worked as a university professor, which is a very well understood career path, and I haven't actually worked in for-profit research labs in industry. But the places I've worked have been not-for-profits. They've been, where I'm at now, Carnegie Mellon Software Engineering Institute, is what's known as a federally funded research and development center. And so the common thread through all these places I've worked is that we do get funding there to do good research, but it's applied research. So it has to be research with a very directed and targeted end in mind. And I think some people would find that constraining. I've always found it liberating because it lets me know that if I do a good job with the research I'm doing, that somebody cares about it. Somebody's job will be different at the end of the day if I can deliver, what I've signed up to do. And I find that, just such a rewarding aspect of the job. And this wasn't even a career path I knew about up front. I was very much more focused on universities and what it meant to be in a university environment. So just being open to trying new things and going other places it's worked out very well for me, and it's been part of the most rewarding part of the job, actually.